Hi, in this video we will talk about conditional probability and then we'll move on to Bayes theorem and we'll also see an example for both of these. Consider this Venn diagram. The outer rectangle denoted by S is the sample space, that is, it contains all the events that can possibly happen. And we are interested in two events A and B. A is denoted by this left side sphere and B is denoted by this sphere. And the shaded region which is an overlap between A, we call it A intersection B. From the Venn diagram it's pretty clear that A intersection B will be equal to B intersection A. So we can also say that probability of A intersection B is equal to probability of B intersection A. And each of these terms, that is this and this, is equal to the shaded region divided by S. Let's call this equation as equation 1 for now. Now what is conditional probability? It is given an event B has already happened, what is the probability of event A happening? Now since we are saying that B has already happened, what that means is our sample space is now reduced to only those events which belong to B. So the denominator here, that is the total number of outcomes possible, is going to be probability of B. That is this sphere. Now inside the sphere, what is the probability of A happening? That is the shaded region, the red shaded region. And what is that shaded region? Probability of A intersection B. So we can say that probability of A, given that B has already happened, is probability of A intersection B divided by probability of B. And on similar lines we can say that probability of B such that, or given that A has already happened, is probability of B intersection A divided by probability of A. Now we will move on to one example for this conditional probability. We are given two events A and B. A represents any given car is white and B is any given car is a petrol car. We are also given with the probabilities, that is, every 1 in 3 cars is white and every 7 in 10 cars is a petrol car. So probability of A and B comes out to be 1 by 3 and 7 by 10 respectively. We are also given the probability of A intersection B, that is the probability that a car is white and is using a petrol engine at the same time, and that probability is 1 by 10. The question here is we need to find out what is the probability of B given A, that is what is the probability of a car being a petrol car given that the car is a white car. So what this means is we know that the car is white, so the denominator is going to be probability of A coming from this equation, probability of A, and the numerator is probability of B intersection A. And since we know both these values, B intersection A or A intersection B is 1 by 10 and probability of A is 1 by 3, that becomes 3 by 1 when it goes to numerator, and the probability of B given A comes out to be 3 by 10. And now we'll move on to Bayes theorem. We've already derived these two equations, this one and this one, and if we try to rewrite them, we get probability of A intersection B is equal to probability of B times probability of A given B. And this equation can be rewritten as probability of B intersection A is equal to probability of A times probability of B given A. And since probability of A intersection B is equal to probability of B intersection A, that means probability of B times probability of A given B, that is this term, is equal to probability of A times probability of B given A. So if we equate these things, we can reach this formula, that is probability of A given B is equal to probability of B given A times probability of A divided by probability of B. Now we'll have a look at one example which will make this theorem a little bit more clear. So we'll again consider two events A and B, A being that the car breaks down. So suppose that you want to go on an off-road stretch, and on that particular route the probability of car breaking down is 1/10. That is, in every 10 outings the car breaks down 1 times. The second event is that the check engine light of the car is on, and the probability of that is 1 by 30. It can be said that once in every month the check engine light comes on for the car. Now when car breaks down, engine light was on once every 5 days. This is also a given piece of information to us. So we can interpret this as, given that the car breaks down, the probability of check engine light was 1 divided by 5. So if we try to represent this in terms of A and B, we can say that probability of B by A is 1 by 5. This line, that is when car breaks down, engine light was on once every 5 days, can be written as this. Probability of B given A is 1 by 5. Since we are given 3 terms, what we need to find is find the probability that a car breaks down given that the engine light is on. That is, we need to find probability of A given B. From the formula of Bayes theorem, we know that A given B's probability is equal to probability of B given A times probability of A divided by probability of B. Substituting the values, we get 1 by 5, which is coming from here, times 1 by 10, which is coming from here, divided by 1 by 30. Solving this, we get 3 by 5. So this is how we can use Bayes theorem.